Hello everyone, and thank you for joining me for today's Thorogood webcast, Developing a Data Lake Vision. My name is Ben Dunmire, and I'm a Business Intelligence and Analytics Consultant at Thorogood. I'll be sharing today's webcast from our Philadelphia office. Before we get started, I'd like to begin by outlining objectives for today's session. As the core piece of the webcast, I'll share a possible approach or framework to follow when developing a vision for a data lake. I'll draw on important considerations when exploring a data lake initiative and pose some key questions that can guide an organization's data lake strategy. While discussing this example path for going about a data lake, I'll share insights from our client experiences and identify tangible illustrations for each stage of the visioning process. This will help to show how varied data lake strategies and implementations can be. We're going to conclude today by outlining how enterprise organizations can begin to get started considering or undertaking a data lake implementation in a practical way, considering their other data assets. Here is today's agenda, which mirrors those objectives. I'll start with a brief introduction to Thorogood, providing a quick overview of data lakes, and then I'll dive into an example of a robust visioning process to follow when investigating and designing a data lake. I'll wrap up with some considerations for getting a big data platform off the ground. For those of you who don't know Thorogood, we are an independent global professional services firm specializing in business intelligence and analytics strategies, solutions, and services with a focus on our customers. In our engagements, we seek to blend an understanding of the business goals with a strong grounding and knowledge of the technical possibilities to create optimal solutions for our customers. We are a global company with offices in London, New York, Philadelphia, Singapore, Sao Paulo, and Bangalore, where we offer a full range of BI and analytics services, things like strategy and roadmaps, requirements, design and implementation, and training and support. Our focus on business goals and our expertise across the business intelligence stack, from source systems to front-end reports, makes us well placed to understand the unique and differing needs of enterprise organizations when they investigate the potential of a data lake. This helps them select and implement the tool and architecture that makes the most sense to meet their needs. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical and health sciences, banking, and insurance. Our clients are some of the leading organizations in these sectors, and we take a lot of pride in the long-standing relationships we have fostered with some of them. Our clients are large, complex businesses, and we rely on our thorough business understanding and deep technical expertise to deliver successful solutions to their business challenges. With regard to data lake considerations, each one of these organizations originates its own data, receives data from vendors or partners, and utilizes market data and external data that all need to be incorporated to best effect. We are independent in that we don't align with a single technology vendor. Instead, we work with a wide array of technology firms in the business intelligence space. This includes back-end, front-end, and analytics-driven technologies. Our technology independence and knowledge spanning the back to the front end of the BI stack allows us to determine optimal data lake design patterns for customers that we work with. So let's get started by quickly discussing how we define a data lake. Fundamentally, a data lake is a storage repository that holds large volumes of data in a variety of formats. The data can be structured, semi-structured, or unstructured, and be retrieved on demand. So what do we mean by each classification of data that I just mentioned? Well, structured data is data that exists in columns and rows and can sit within a traditional relational database. Semi-structured data means data that doesn't reside in a relational database, but that does have some organizational properties that make it easier to analyze. Think of something like XML or JSON. And unstructured data encompasses anything else, such as emails or audio files. With current prevailing mass data storage tools, such as data warehouses, before we can load data, we first need to create tables and structures in the data warehouse to accommodate and create relationships between the data. We then need to extract data from sources, transform the data to match the format of the tables, and finally load it. When dealing with a data lake, the data can either be transformed in a certain format or simply loaded in its raw or native format from the data source. Some organizations we work with take advantage of the data lake's ability to handle raw data and use the lake as a staging area to load data prior to transforming it for downstream consumption. Other organizations use data lake folders to store copies of the data that exist in structured database tables. The data lake can be used for either or both purposes, but crucially requires less formal processing. Data lakes are capable of storing data at relatively low cost as compared to other traditional data storage solutions. By virtue of the fact that lakes can leverage open source software like Hadoop and sit on low-cost commodities hardware, or use something like Azure or AWS as an example. They are also capable of handling a scale of data which dwarfs traditional data storage tools. Given the relative lack of processing required to load data into a data lake and the low cost of storing and maintaining data in the lake, this enables the data lake to be more agile and meet business needs faster than many organizations are used to in this domain. Data sets and formats that could never before be stored can be loaded and accessed for analysis with relative ease and speed. And finally, the data lake is an enablement tool that empowers data scientists and analysts within the organization, provides access to potentially all of the organization's data from one central location with the ability to analyze cuts of the data on an ad hoc basis. It can also be used to mirror process data that exists in data warehouses or the staging area before data is processed and consumed by business users. Ultimately, just as there are varying reasons why an organization may look to adopt a data lake can play different roles within an architecture and different purposes for end consumers of that data. Now that we have a baseline definition for a data lake, let's explore a possible approach that an organization can take to develop their data lake vision. As with many data and analytic endeavors, the process begins by understanding and identifying business drivers. Why am I doing this, and why does it matter for my organization? It's crucial to have a complete view of the data challenges your organization is facing, the question your analysts and scientists are trying to answer, and the opportunities to gain new functionalities and access to new impactful data sources. A data lake can come in many forms and serve many different purposes. It's necessary to understand what goals are trying to be accomplished, as it will dictate how a data lake or other data initiative is designed. I'll share a few common business drivers that we've encountered at customers when exploring a data lake. There are surely many others that impact one's data strategy and may be relevant to your organization's current state. On the screen, I have a few common reasons why an organization may benefit from a data lake. I'll go in a bit more depth on a couple of them. To start with, users are empowered with a wide array of data at their disposal to be analyzed in their tool of choice. A data lake enables data scientists to explore use cases by providing access to any enterprise data securely and at the right level of detail, and allows analysts to connect to a variety of unaligned and volatile data sets to produce recurring or ad hoc insights. The data lake offers an organization the ability to operate existing systems with reasonable data volumes, such as a long-standing data warehouse, while retaining access to a large volume of historical data in the lake. With large volumes of internal data and increasing volumes of external data, a data lake can service massive amounts of data while being responsive to business inquiries. Data lakes can store and catalog various types of data, not just column-oriented and structured data. This allows analysts and data scientists to gain new insights from unstructured or semi-structured data sources that they were previously unable to access and integrate alongside the more traditional data. So this includes things like less structured files that are produced by business users like images, emails, video, or audio that's been captured and recorded. There is a large amount of untapped potential from these new types of data sources. So these are just a handful of the common business drivers we've seen from our customers that are leading them either to consider or adopt a data lake as part of their data architecture and landscape. One of our clients was recently aiming to consolidate several siloed data warehouses into a single platform to promote more synergies, both from an infrastructure and data availability perspective. Really, the key point is that the way you would design a data lake varies greatly based on the distinct set of business drivers that you have. After identifying the data goals that we're aiming to accomplish and the opportunities to provide value to a given organization, it's important to understand how a data lake fits into an overall data strategy. With any investment, it's important to consider the present and the future, and how to maximize return on a data investment. So how will a data lake fit alongside other systems and align with organizational objectives? And is a data lake the appropriate platform to address the drivers coming from my business? As we think about these questions, let's look at a framework we use to consider data strategy. We'll begin by looking at a continuum to understand the different methodologies for data modeling and storage, and how a data strategy should aim to cover all aspects of the user continuum. We start by thinking about the different users and use cases for data within an organization. Over on the left-hand side of the continuum, we have a pretty broad user base that may be consuming different BI and analytics in a more descriptive means of delivery. Think of this as standard or structured reports or something like printable financial reports. In the middle, we reach diagnostic reporting with a smaller user base. You can think of this as ad hoc BI and analytics, where users ask specific questions of the data and are able to slice and filter reports to derive those insights. Tools like Tableau, Power BI, or Click usually fit into this group. On the far right is the more niche user base, like data scientists or power users with a background in analytics, who are performing more predictive types of reporting, like running algorithms or creating analytic models to forecast pieces of the business. As I said, this is a continuum, so there aren't solely discrete buckets, but users and reported needs across these groupings. The next topic we come to, and many of you will be familiar with, is how the data is stored and modeled to satisfy these use cases. Descriptive reporting relies on an enterprise data store, something like a data warehouse, which is in a stable environment with heavy processes around it. These data stores are challenging to change and often take time to get new data into them. The diagnostic analyses can be supported by an ad hoc data store, which is a bit more flexible than a data warehouse with lesser processes and rigidity. Here, you're able to get a sight of new data sources and incorporate them fairly quickly. Ad hoc data storage is a place to perform analyses and experiments in a sandbox-like environment where scientists try to uncover what's valuable and where insights lie in a larger raw data set. There is minimal process around this data store, which gives users the flexibility to transform in the model without any rigidity. This type of data store does present the challenge of having to point users to a single data set and to collaborate on a single workspace. Now, while the groups of users do sit on a continuum, there is certainly value and a need for users to reach data stored in each of these systems. A data scientist analyzing raw data may need to pull enriched master data to answer their business questions. So an important question to address is how do we allow users the flexibility and access to take advantage of all platforms and data assets together? An organization's overall data strategy should bridge the gap between data structures and provide means to access information across the platforms. A robust data strategy will recognize where synergies exist and cover off all scenarios and usage patterns for users across the reporting, analytics, and data ingestion continuum. In the past, we largely think of just the leftmost entity, a structured data warehouse to support standard reporting. With enormous growth of the data availability, presence of self-service tools, and analytic-minded individuals, among other factors, we see an effective data strategy as one that supports all types of usage in a combined platform or architecture. So to answer the question, does a data lake fit into my architecture and strategy? It really depends. By exploring some of the topics covered in this slide and in some later slides, and thinking about how an organization's data is servicing users and where gaps may exist, we can develop a vision for what type of data platform or integration of platforms fits in an overall strategy. So now that a holistic view has been taken of an organization's data strategy and where a data lake may fit in, it's a good opportunity to continue thinking about the future states and iterations and how data needs and the possibilities that are available will evolve. By thinking about what's next when investing in a data lake, you can be more agile and incorporate new functionality and maximize longevity of the data lake. So we often consider starting small with the data lake to fully understand how it will impact an organization and how to get the most out of it. While the initial scope may be small, we find it crucial to anticipate where future asks will come from and how the system will likely grow and identify gaps that may need to be filled. Thinking ahead will drive toward a robust and scalable solution. Before really diving into a data lake build, we find it valuable to do a thorough analysis to anticipate where future asks and future enhancements will come from. I've captured a few areas where we've seen opportunities for data lakes to expand and grow as the platform matures. I won't go through all of these, but we'll touch upon a few of them. One of the main synergies we see with data lakes is incorporating or aligning it to enriched information. Often, a data lake stores large amounts of relatively raw data, so forming relationships with something like master data or enriched data provides more value to the data lake. A common example we see is integrating a data lake with an existing enterprise data warehouse, whether that's the data lake storing cold data or the enriched information sits alongside the raw data lake. Another common ask is provisioning end-user workspaces for individuals to explore the data lake via analytical models or self-service reports or queries. These sandbox-like areas promote the discovery of valuable data trends and insights, which is one of the ways a data lake can be really, really valuable. The availability of powerful workspaces helps to promote user adoption and empower certain users with data to drive their analyses. Seeing as data lakes often begin with relatively small data volumes from a few sources, they often ramp up quickly in terms of volume and types of data. We see scenarios of needing to integrate with brand new data sources and systems, so having a robust and flexible data lake to capture data from new systems and scale up is pretty important. It also may prove cost-effective to store data that was once in a warehouse-type system in the lake. As an example learning during this visioning stage, an organization we work with was considering a data lake and anticipated there being requests to store large volumes of history in the data lake and also align the lake to their organization's master data down the road. By having an idea where future enhancements will come from, considerations can be made to the data lake strategy, and the platform can be designed to provide a strong return on investment and have continued value in the organization. So when thinking about what a data lake is and what it may become, we've seen some common trends across clients and in the industry that maybe help to shape the thinking of someone getting started with a big data platform. I've consolidated those trends into a few groupings. The first stage of a data lake can be a landing area for raw data, which houses information from internal and external sources. There are often only a few users who are able to work with and derive insights from this data. As the data lake matures, we see the need for end-user workspaces or areas to allow scientists and analysts with the tools and freedom to investigate the data and ask their pressing questions. Here, users can apply transformations and structure to the data to be able to model it. As users begin to understand the data and identify where value or trends lie, it's helpful to see the data lake information alongside information they're more familiar with working with, something like a data warehouse. By aligning it to enriched data, users can begin to associate insights from the lake with existing enterprise reports and analytics. As users begin to align a data lake's raw or minimally transformed data with enriched information, it becomes valuable to integrate the systems and design a formal process so more users are able to take advantage of synergies between raw internal and external data with well-defined stable systems. An example of this we've encountered was a data lake platform that was initially planned to act as a raw landing zone of internal data. But the technology group identified that users would likely want to integrate the raw data with their warehouse to provide enrichment or possibly use the landing zone as a source for their existing warehouse. Understanding these possible requirements impacts how the lake is technically designed and implemented. In this stage, we've also seen cost-saving opportunities in offloading historical or cold data in a data lake where storage costs are low and data latency isn't that impactful. A final stage we've seen a data lake progress to is becoming a data asset that enterprise applications are built off of and other business-critical systems rely on for data. As we think about a data lake vision, it's prudent to think about what the data lake can become and where value may lie for your organization. So the first three stages in this example visioning process are focused on understanding all the requirements and assessing risk and fit in data strategy, and really thinking critically about all the technical possibilities revealed by a data lake meshing with business needs. With that knowledge, we can progress to consider the technical options and become more aligned with what the implemented lake will look like. A data lake may contain multiple elements within its data platform offering, and it is certainly not constrained by a single tool or a way of working. At Thorogood, we think about how a technical approach can be married with business goals to deliver a compelling and valuable solution. That same thinking applies to the data lake vision. What technology selection and architecture is going to promote the most valuable solution for my specific needs? The data and analytics technology industry and current landscape is constantly evolving and changing, so it's necessary to understand what's available and catalog the various technical options to deliver on a data lake vision. It's of paramount importance to align the technical approach with business goals and future enhancements to ensure that the data lake provides value immediately and in the future. So I've shared a few thoughts for technical requirements and considerations on screen, and I'll touch on a few of them. One of the first questions we hear is, should a data lake be hosted on-premises or in the cloud? This is vitally important to think about as it relates to an organization's overall data and infrastructure strategy and to their existing architecture and location of existing data assets. We can answer why either option or a combination of both an on-premises and cloud architecture may meet the business needs. The next question we often hear from clients is, what tools are out there and what are all my options? It's helpful to think about the art of the possible. What technologies exist in the current landscape? How do they work? What are their benefits and drawbacks? And how could they be leveraged to deliver on a data lake vision? By understanding what is possible alongside known business drivers for your data lake, you can develop compelling architectures to move forward on. Another relevant technical consideration is designing a data lake and its components that are tool agnostic, or in other words, don't constrict which reporting or analytics tool integrates with the platform. We've seen more innovation in reporting, dashboarding, and analytic tools as opposed to data platforms, so you want a data lake to work with a wide array of tools in order to have longevity and robustness. It's also imperative to think about data ingestion and how a data lake can consume from internal and external sources of data. There are many things to consider when thinking about a data lake and how it will be designed, what technologies and which ones to use. Some of the points on screen provide a good starting point to think about during this data lake vision. So to speak a little bit more specifically about how a technical approach can be designed with business drivers in mind, I'll briefly share a depiction of a data lake architecture from work at a healthcare and clinical research company. One of those important drivers for this solution was to have a robust external points of collaboration as inputs from various sources and outputs to provide to customers. This required a flexible and scalable solution that adapts to the technologies and types of data provided by vendors and requested by customers. Rather than creating something new and disjointed from other IT investments, it was important to design a solution built with an existing architecture, leveraging familiar tools. It was necessary to design a solution that stored data so it was accessible in ad hoc one-off analyses, as well as more stable process structured similar to a data warehouse. A data lake may contain multiple elements and serve multiple purposes, which is why it's important to consider the data design alongside other pieces of the visioning process. So most vital to this design are the external points of collaboration. On the left-hand side, a landing zone behaves as a data collection platform, welcoming different types of data from different sources. The data lake data capture mechanism needed to coalesce with different technologies and processes from vendor and third-party data sources to ensure customer needs could efficiently be met. On the right-hand side exists a collaboration point with customers where users that have access through an external interface to the appropriate data and reports. In the stable data storage and modeling structure on the lower portion of the diagram, this collaboration manifests itself in access to something like Tableau or ClickServer dashboard. Here, users provide the requirements to be met by the company supplying data via the lake. In the ad hoc upper portion of the storage and modeling segment, users have the power to do one-off analyses and exercises for any use case that pops up. Here, users will employ analytic tools or self-service reporting tools for the analyses. This approach is an effective way to determine what data should be applied to a stable structure for more repeatable insights. So we can see the dual storage and modeling tracks within the data lake environment, storing raw data in the ad hoc structure and enriched data in the stable structure. A strength of the design is the flexibility and agility to move data between the tracks to support customer needs of newly acquired sources or previously speculative ones. By designing a consolidated data repository that isn't defined and siloed by a business group, it creates a more flexible and accessible data architecture that all users are able to pull from. So let's jump into the last piece of the visioning process. The final step is to consider what the implementation and user rollout will look like. What data sources will you get started with, and how will the system be built? Which users will get access first, and at what point in the development cycle will those users be introduced to data? To ultimately make a data lake initiative successful and a valuable data asset, it's important to have a plan for user adoption and an approach in place to empower users to explore the lake. We see significant synergies between implementation and user empowerment, as the user base can often guide priorities and provide valuable feedback as to what's working and not working when building out a data lake. When we at Thorogood think about implementation and user rollout, we often think about the data, the tools, the people, and the process. It provides a holistic view of what's happening and what gaps may need to be addressed. The data. What information is being included in a data lake, and how is the priority being set for inclusion in the lake? It's often prudent to start with a few data sources and organically grow the lake to understand what data is available to your organization, and of that data, what provides value. It's important to think about the nature of the data and how it's to be used. Is it valuable as raw information, or does some metadata or transformation need to be applied to make the data more consumable? The tools. What technologies are available to build a lake, and what reporting and modeling and analytic tools exist or are planned to be put to use within your organization? As we spoke about earlier, a data lake should be tool agnostic and able to mesh with current and future data digestion tools. Thinking about the implementation and user adoption of a data lake, what infrastructure and technologies are available to me or within reach? What support systems and teams are in place? And where does experience lie in various consumption tools? An effective strategy often leverages existing tools without creating bottlenecks for integration with new technologies. The people. Does your organization have individuals with the skills and capabilities in place to deliver on the data lake vision? It's important to align the appropriate individuals to an initiative and a role that best fits their unique skill sets and who are in sync with the business drivers. In today's data landscape, individuals with business and technical acumen for a data platform journey such as the data lake help to lead to a successful delivery. And the process. We often see implementation or rollout processes becoming over-engineered or cumbersome, which interferes with delivering on a vision. With a data lake initiative, it's important to think about how the platform will be designed and built, how data will be made available to users, and how the lake will grow in the future. So an example of a few topics that have been of particular interest to one of our clients, an organization wanted to create an operational data store or data lake servicing raw internal data. Apart from the technical nature of data and possible options to build the system, we also spoke about the people and process to drive it to success. In this case, there were a few power users who were eager to get access to the raw data. So as opposed to delivering the full data set all at once, we considered releasing incremental groups of data to get into the user's hands quickly. This would allow for continuous feedback, answering if the information was useful and should be continued, or if the process needed to be adjusted. It also would allow for prioritization of data to be included in the subsequent releases. So we've gone through an approach to develop and then deliver on a vision for a data lake. After identifying business drivers and considering fit alongside overall strategy, focus shifts to the design of the data lake, considering what future states and enhancements will look like, technologies available in the marketplace, and how to promote rapid adoption to deliver valuable data to the investment. So now that we've touched on the example approach, let's quickly wrap up with how to fulfill this vision. So what are some of the things that are important to consider when thinking about or exploring implementing this lake? As evidenced by our discussion today, it's imperative to identify and define the business drivers behind consideration for implementing a data lake. What are some of the use cases or business challenges that need to be solved? What type or types of data would you like to leverage? It is certainly possible to start small with a data lake, using a few data sources and a POC-like activity to understand how it fits into your architecture and understand any additional business drivers. A data lake needs to be flexible, able to bring data in and send data to various technologies, so it should work well with other tools. You can pick the technology where experience lies and works with other technologies, and one position to work with existing and future technologies. A data lake should also be considered alongside other assets and initiatives to see where it fits into an existing architecture. For example, it may involve putting raw or enriched data into the lake that already exists in another repository. So these are a few important things to consider when thinking about a data lake, and certainly a good place to begin contemplating the topic. So if you'd like to learn more about any of the topics we discussed today or understand how a data lake could fit into your existing architecture, we'd be happy to assist you. Feel free to reach out to me if you have any questions about the content we presented or curious on the topic. Here at Thorogood, we approach all projects in a way of balancing business goals and value with technical possibilities in order to achieve maximum potential for our clients. We help our customers with everything from implementations and individual solutions to how to get started with the tool to developing enterprise-wide BI strategies and roadmaps and many services in between. We do have a number of on-demand videos available to you if you'd like more information. In addition to the few that I've shown on the screen, you can also see our full list of videos on our website or via our YouTube channel, Thorogood BI, or reach out to me afterwards. My contact details can be found over on the slide. Thank you very much for joining us, and have a great rest of your day.